Hello, people. Hello, 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 hello. High school, how are you doing? Okay, now we are going straight into the video we've made for you today. Is indices laws. Indices is a term in mathematics that means powers. Powers a number is raised to. So it's plural for index, index number. Okay, can we go? Can we go? Now we've made this beautiful video. These are the laws of indices. Now don't get confused, don't get thrown aback. For those of you in J3, this is a revision class. For those of you in J2, this is a revision class. For those of you in J1, I don't think you've seen this before, so you have to listen very, very carefully. So can we go? Can we hit the ground running? Okay, now first things first, the first law. What does the first law say? Good, that's the first law. It says a to the power of m divided by a to the power of n is equal to a to the power of m minus n. Don't be scared. When we have examples, these will ease out for you. Trust me. The next law says a to the power of m dot a to the power of n is equal to a to the power of m plus a to the power plus n. Sorry, I'll go over that again. A to the power of m dot a to the power of n is equal to a to the power of m plus n. Like I said, examples will make this very, very easy. Next up, we see the next law. A dot. Now, what does dot mean in math? Dot, as you go higher in math, dot is a symbol for multiplication. Yes, you heard me right. Dot is a symbol for multiplication. Now, A dot B, all brackets, m is equal to, it's the same thing as expanded a to the power of m, b to the power of n. Next law, a to the power of m, all brackets n, is the same thing as a to the power of m times n. Now this, a to the power of 1 over n is equal to the ninth root of a. The nth root. What I mean by n? N, good. The nth root of a, not ninth root. The nth root of a. Now let me do you a little explanation to that effect. Now, this is square root. It doesn't carry any 2. Naturally, we know it's square root. This is cube root. This is fourth root. Then obviously this is the nth root. Good. N is a symbol in mathematics we use to represent an unknown, especially, to the nth figure, to the nth power. So it's an unknown figure that's popular. X is popular in algebra. N is popular for quantities. Good. There is no law that says that. Okay. Can we continue? Can we keep going? Okay. Where did we stop? Right here. Good. Now the next law, we've treated these laws 1, 2, 3, 4, 5. 5 laws. Okay. A over B to the all brackets m is the same thing as a to the power of m over b to the power of m. As long as, look at this, b is not equal to 0. This sign means not equal. Good. Next up, we have a to the power of 0 is equal to 1. A to the power of 0 is equal to 1. Even if a is 1,000, if it is to the power of 0, by the law of indices, it is equal to 1. What are laws? Laws are things you obey. You do not question laws. You do not ask how they came about. Am I suggesting that you shouldn't sometimes query what you see in mathematics? Now, mathematics is not a hook, line, and sinker thing. Mathematics has a logical backings. So these things have been proven, and they've been proven to be correct. So they are logical backings to the math we see all around us. So a to the power of 0. A here represents any number. B here represents any number. So when A, even if it's a million, as long as it's raised to the power of 0, what does it come out as? 1. The answer is 1. It's as simple as it is. just as long as a is not equal to 0. If a is equal to 0, that doesn't apply. If a is equal to 0, in the first place, it can't even be solved because 0 cannot be raised to any power. Okay, good. Sorry, my line is so bad. We'll manage it. Okay, a to the power of minus m. I need you to see that very well, so we'll take that again. A to the power of minus m. Good. It's the same thing as, this is common for you in standard form. A is equal to 1 over a to the power of m, as long as a is not equal to 0. Next up, what do we have? A to the power of m over n. A is raised to the power of m over n is equal to the nth root of a to the power of m. So this is very, very important when you start solving sorts. When you start solving sorts, this is very important so I said when we start solving sorts, this is so important. Where's my marker? Okay, so this is crucial when you start solving sorts. A is raised to the power of m over n is equal to a raised to the power m, the nth root. Okay, can we go to the next page now? Okay, finally, this is our last page for this session. Okay, now the square root, this is where we are. The nth root of a. Listen, the nth root of a to the power of n is equal to a. Without waiting to go for our exercise, I'll prove this to you now. Let's do this. 5. Take for instance. 25, sorry. 25. 25. The square root of 25 to the power of 2. What is it? Can you solve it? Show me that it is equal to a. That's your first assignment. I need you to submit it immediately you see this video. Prove to me that this will give me a. If you can figure that out, I'll know you are a real genius. Yeah, okay, can we go ahead? Okay, now the next one is this. How do I read this now? The nth root, yes, of a bracket m is equal to the nth root of a to the power of m. Of course, that only makes sense. Which is eventually equal to a is raised to the power of m over n. Now, if you remember the page we were before now, you see that this is exactly true. Then this one is the mth root of a and the nth root of a and the nth root let me start again. The nth root of the mth root of a is equal to the m dot nth root of a. I'll show you this with an example so it will become very, very clear to you. Finally, we are almost done. Okay, a dot b, the nth root of a dot b is equal to the nth root of a dot the nth root of b. Then the last one I have here, a over b, the nth root of a over b is equal to the nth root of a over the nth root of b, just as long as b is not equal to 0. So this is what we have, and thank you very much for listening. Right about now, we will go and take some exercises. So you stick around. Thank you.